moment is simply to learn how to use these identities. The ultimate reason, you might want to catch this because I bet this is a journal question. The ultimate reason we care about these identities is it's going to allow us, in the next chapter we're going to try to solve equations, and they're going to be messy. And you can use these identities to take it and make it much simpler and much easier to solve. So identities allow you to take complicated expressions and make them simple. I have no idea what number it is. This whole chapter is applying properties, yes. Okay, which is correct? More simple or simpler? Simpler? This didn't sound right. Okay, so in this case, what you're basically going to do here is you're going to apply your algebra knowledge, and then you're going to throw these trig identities in. Now, this is when it's already all sines and cosines. Yeah, exactly. If I want to, excuse me, could we end the conversation, Timothy?
What?
You are distracting others.
Sorry. We're just talking about on how I think it is.
All right, so, yes, if you're going to add fractions, how does one add fractions? You make common denominators. So what would the common denominator be here? Okay, what is 1 plus cosine? Okay, so now that you have them where you can see them, I need to make a common denominator. What's the common denominator? Yeah. And that would be times the quantity 1 plus cosine, so it would be important that you put that in parentheses. Okay. And this is just like you learned to make common denominators with variables last year. What's the first fraction missing? It has a sin x on the bottom, but it does not have the 1 plus cosine x. So I have to take it times 1 plus cosine x in both the numerator and the denominator. Okay, so what will happen when I multiply the numerator? Yes, I will get a cosine x plus a cosine squared.
At least these are easy to multiply.
Yeah, that's coming. That will happen. Okay, now, the second fraction has 1 plus cosine, but it does not have the sign.
You're only going to make it FOIL cosines and letters?
Absolutely, and factor them. And so that will be sine squared. Okay, now, I said this is supposed to make it simpler. That doesn't look a whole lot simpler. But there's now one of the identities screaming at you. Use me!
Cosine and the sine squared.
Yes. We have back here, I have horrible colors for this. Okay, so I have cosine squared plus sine squared. And that's number 6. So yes, that whole quantity just became 1. So now I'm going to rewrite what you have left so you can see here, because now something else cool can happen. By the way, you don't want to just multiply that denominator together, usually, because you're usually going to try to get something to cancel. Does anybody see anything that's kind of similar? Isn't cosine x plus 1 the same as 1 plus cosine? Those are the same quantity, and you can cancel whole quantities. So yeah, that bit is gone. What's left? You're left with 1 over sine, which actually I would consider that an acceptable answer, but it could also be what? It's actually identity number 1, so you could even take it as far as saying it's cosecant. So there's an example of what trig identities can do for you.
Nothing.
You start out with just 2 big messy fractions, you got down to 1 term. That's pretty helpful. If you're trying to solve equations with this stuff in it, that makes it way easier.
Why are you going to make it FOIL? Why will you make it FOIL letters?
You've been foiling letters forever. This is just more letters.
No, now we're FOIling words.
Okay, we're foiling words. Wait, sort of, kind of. Well, Luke, you asked for it. Guess what? It's in the next problem. Yes, that's cosecant. Because, all right. so I want you to simplify this one. You have a 1 plus tangent x. Children, the tendency is to look at this and go, oh, I have 1 plus tangent x, and if I squared it, wouldn't it be number 7?
No.
So, how do you square a quantity? Because can I just distribute the square to both of them? No, you got to take it times itself. So you have to actually take 1 plus tangent x times 1 plus tangent x. And so that identity number 7 is still going to play in this, but there's a little more to it. Yes, there'll be 2 tangent x in the middle, and a tangent times tangent will make a tangent squared. So it's normal foiling. This is tangent. Okay. Okay. Mathematicians, I think I've talked to you about this before. Mathematicians are lazy. Technically, tangent x times tangent x should be tangent x squared like that. But mathematicians don't want to have to write those parentheses all the time. So we throw the square up here, but it means the entire tangent is squared. This would be 1 times tangent plus 1 times tangent would make 2 tangents. Yes, it would. If you wrote it like this, like that, you're squaring the x, you're not squaring the tangent. So, yes. So, yeah, it matters. It has to be in the right place. That's a very good question. Okay, I can here in a minute, because if you notice there, I haven't finished carrying the rest of my problem down. I still got this minus 2 tangent x back here yet. And yeah, those 2 tangent x's are going to cancel. And once those are gone, all I have left is 1 plus tangent squared, which is identity number 7. And so it all comes down to a nice little secant squared x.
How is that number 7?
1 plus tangent squared equals secant squared. It becomes secant squared.
Okay, now I see it. Okay, I thought that was just all 1.
No. This whole quantity becomes secant squared. So,
How does it get?
maybe, yeah, today. Okay. And, all right, some other algebra skills you're going to have to be able to do with these is sometimes you're going to help yourself by being able to factor them. So we have to see if we realize that we can factor with trig functions in it just like we factor everything else. So if I give you a nice little trinomial here, and you think, ooh, big numbers even to factor with, no less. But okay, does that scream I'm quadratic at you? I hope. It's sum squared, sum to the first power, constant number. It's quadratic. How do you factor a trinomial?
Quadratic, okay.
You do the 2 binomial thing.
Are you serious?
Yeah.
Are we really going to do this with trig?
Yeah, we are. Okay, so what numbers do you want to try to make 15?
2 and 8.
3 and 5.
It's either got to be 3 and 5 or 1 and 15. Okay, so I'm hearing try 3 and 5. Now, it's a cosine squared. So since it's a cosine squared, there has to be a cosine x in both of them. I didn't leave myself enough room here. So it's going to be a 3 cosine, and then I'm going to try a 5 cosine x in the other one. Okay, so we're trying 3 and 5. Cosine times cosine will make cosine squared. Okay, factors of 8 to try. Okay, 4 and 2. Anybody? You want 4 and 2?
2 is negative.
You're still going to check insides and outsides. Does 20 and 6 going to make me a 2 in the middle? No. Okay, before I go that route, do realize you need to check what happens if I switch the 2 and the 4. You haven't eliminated 2 and 4 yet till you switch places. Yeah. That's going to give me 10 cosine, and that's going to give me 12 cosine. So what do I want to do with the signs?
Negative 4.
Yeah. Negative 4 and positive 2 then, so I make a negative 8 in the back. I mean, this negative 8 is what I'm talking about. Did I do that wrong? Okay. They told me to make a negative 4.
Well, they're wrong.
Okay. So positive 12, negative 10. Yeah, and now make positive 2 into your factoring. Right now, I'm asking you to do is factoring. That's it. You're done. You factor. That's for right now. I just wanted you to factor the problem. That's it. Those are your answers. You just got factors. We're just practicing our algebra skills mostly. No, we aren't solving yet. We're just factoring.
Oh, so what's these identities?
We will. Next chapter, we will solve them, set them equal to 0 and solve for x.
When we have a number, hold on. When we have a number in front of these, then how does that affect the identities?
Good question. Good question. Good question. We should talk about that. Okay, let me back that up a second. Okay, Gabriella just asked me a really good question about these identities. What happens if there's a number in front of one of them? Well, okay. If it's one of the first 5, it's perfectly fine if I put a 4 here. I put a 4. I take that times 4 before on top. That's legal. You can have a number, and as long as it's the same number, that's perfectly legal. The other thing I should tell you, particularly about the first 5, and notice why am I only talking about the first 5? There's only one quantity on each side. There's no pluses or minuses here. Okay, these first 5 can also be any power. I can do cosecant squared is equal to 1 over sine squared. I can do cosecant cubed is 1 over sine cubed. You can put any power you want on the first 5.
Wait, but what if we do the other one?
6, 7, and 8 are from the Pythagorean theorem. They only work for squares. You cannot change them.
You can't put like a 4.
You would, where would you put the 4? Yeah, cause
Leave me alone here.
you can't just put the 4 on the cosine squared, because that wouldn't be the same. You'd have to be 4 cosine squared plus 4 sine squared equals 4. You'd have to take every term times 4. Yeah. That you're probably not going to ever see.
Okay. Wait, but on the ratios though, how does that work? Like if there's 4 tangents?
It's 4 tangent is 4 sine over cosine, because the 4 would be on top. Yeah. All right, now back to the ranch. Okay, here we go. Make me proud. I want you to factor this one. Actually, I want you to simplify it. You're going to have to simplify it by factoring it. I'll tell you that right now. But this is one that makes me cry multiple times. That's secant cubed. It got that kind of high. Over secant squared x minus 4. Okay. Why can't I cancel a secant squared into secant cubed?
Does that make it?
Because they have the minus number on the
Yeah, there's subtraction. You can't cancel when there's adding subtracting terms unless you cancel the whole quantity. So our only choice is to try to factor these. Do you recognize what it takes to factor these? You know the rules for both of these. This one's like if I just did plain variables. That's perfect squares, difference of squares. You know how to factor that one. And this is the perfect cube rule. Yeah, you just have to do it and throw a secant in instead of just an x. Okay, so perfect squares factor easy. How do you factor perfect squares? We'll do the bottom first. It's the one that's conjugates. So it'd have to be secant x and secant x. To make 4 would have to be 2 and 2, and then what did you always do with the signs on these? Yeah, you gotta have one of each sign, doesn't matter what order. So perfect squares are the easy one. Okay, perfect cubes.
Those are the evil ones.
Let me remind you about the cube rule. The cube rule has a binomial times a trinomial. What went in the binomial? The 2-term part, you just uncube it. Just take the cubing off. Okay, now, how did you get the trinomial? You square whatever you wrote in the first spot, you square it. It's the middle term. Yes, it's an AB. Do you add or subtract? It's opposite. If this is a minus, you do a plus. The next one is always a positive because you square it. And anytime you square something, it's positive. So it's always b squared. That's how you factor perfect cubes. So in our case, it's the same thing. It's just with a secant instead of just an x. So you have to go, what are those uncubed? So it'd be secant x, but what number are you cubing to get 8? 2. 2 cubed is 8. So it's secant x minus 2. And then now, you just follow the pattern. You square whatever you wrote in the first spot. So it's secant squared. Okay. Then you change the sign, and you multiply whatever you wrote in those two spots. So it's 2 secant x. And then you square whatever you wrote in the last spot, which would be plus 4. Okay. And if you'll recall, this trinomial will never factor farther. You'll never have to factor. Get rid of that book. Book away. Now, what will cancel? Yeah, we can ditch the secant x minus 2. The rest of it will not break down any farther, so I'm sorry, we're stuck with the rest of it. But it's, what do you mean by A and B? You could try to factor it. It won't ever work. This is never factorable. You won't ever get it to break down. It looks like it should, but it won't. So if you do that rule, the trinomial will never go farther. So we would be stuck in this case with that much stuff.
Oh, we haven't done yet. I kind of like it.
Oops, stop.